So if x belongs to R and delta x is equal to x square plus x, 2x minus 1, x plus 3, 3x plus 1, 2 plus x square, x cube minus 3, x minus 3, x square plus 4, 2x. If this is equal to a naught x raised to 7 plus a1 x raised to 6 plus a2 x raised to 5 plus a3 x raised to 4 plus so on a6x plus a7, find a7 summation k equal to 0 to 7 ak a naught. Right, friends. So if x belongs to R, delta x is equal to x square plus x, 2x minus 1, x plus 3, 3x plus 1, 2 plus x square, x cube minus 3, x minus 3, x square plus 4, 2x. See, we need a7. a7 is the constant, right, on both sides. I'll copy this first. Now, a7 is the constant in this, correct? A naught x raised to 7 plus a1 x raised to 6 plus a2 x raised to 5, so on a6x plus a7. a7 is the constant, so I'll substitute x equal to 0 on both sides. What will happen? This side will be 0, minus 1, 3, 1, 2, minus 3, minus 3, 4, 0. That side will be what? All are zeros except a7. We just need a7 value. Now, how will I get this? a7 by Saras method, 0, minus 1, minus 3 into minus 3. That's going to be minus 9. 3 4s are 12. Correct, students? 3 2s are 6, 6 3s are 18. Plus 18. Now, baki dono 0. So, answer we are getting for a7 is 21, I suppose. Correct? Students?
Yes.
Right now. For second one, we need sum of all coefficients. Correct? Now, sum of all coefficients kaise milenge? What we have to substitute? X equal to 1 we have to substitute. Correct? Now? So, in this, I will substitute x equal to 1. In this, if I substitute x equal to 1 on both sides, what will I get on that side? On that side, I'll get summation ai, I equal to 0 to 7. On this side, what will happen? That will be 2, 1, 4, x equal to 1 dalenge, 4, 3, minus 2, 1 minus 3 is minus 2, 5, 2. Correct, students? So, summation ai from I equal to 0 to 7 equal to, let's apply Saras method again. 2 3s are 6, 6 2s are 12, plus 4 plus 4 4s are 16, 16 5s are 80. Then negative products. We have to take negative products. That's going to be this one. 4 3s are 12, 12 2s are 24, but that will become plus 24. 5 4s are 20, plus 20. Minus 8. Last one is minus 8. Fair enough? So we can see that, see 12 plus 4, 16. 16 plus 24, 40. 40 plus 80. What is 40 plus 80? 120. 140. 140 minus 8, 132 is the answer. Is it clear, students?
Yes.
Students, is it clear? Now let us try to understand which is the next part. Let me discuss the next part also. Next part is also a good idea. We need a naught. What is a naught? A naught is the leading coefficient. Correct, students? A naught is x raised to 7 ka coefficient. So how do we find out x raised to 7 ka coefficient? Na? I'm going to expand this one. Don't do any row operations. I'm going to expand. That looks scary and sounds scary, but yeah, it's not scary. Let me explain you. See, what are we interested in? We are interested in A naught, which is x raised to 7 का coefficient. Yes or no, students? A naught is x raised to 7 का coefficient. हम Saris expansion से expand करेंगे. If I expand, every time we are interested in only one thing. X raised to 7 form हो रहा है कि नहीं? If it is forming, what is the coefficient? Do you understand? If it is not forming, we'll neglect. Are you understanding, students? If I multiply these three, see, I'll show you in first principal diagonal only. Imagine if I'm multiplying these three in Saris expansion, highest power is what? X square into x square, x raised to 4 into x. X raised to 5 is the highest. X raised to 7 form नहीं कर रहे हैं, so हम product करने का जरूरत नहीं. Next, multiplying these two with this. Either x highest power is what? X into x cube, x raised to 4 into x raised to 5. No need to multiply them. Again, multiply these two with this. Highest power is x into x square, x cube into x raised to 4. Even we don't need to multiply these. Because x raised to 7 abhi tak aaya hi nahi. Are you understanding, students? Let us take reverse products, negative wala products. This is one of them. Iska highest power is what? X into x square into x raised to 4 only. Correct, students? Next, iska x raised to power is what? X cube. This is like very simple. All are linear terms. X cube is the highest power. Last one that we are left out with, we completed 5 of the products. None of them have x raised to 7. This is the only thing with x raised to 7. Check out. Highest powers are x square into x cube, x power 4 into x cube, that is x power 7. Now, what is the coefficient of it? Since it is negative, ये वाला term लिखते हैं, बाकी सब में x raised to 7 नहीं है, so we are not writing. This term is minus x square plus x into x square plus 4 into x cube minus 3. In this, whatever is the coefficient of x raised to 7, that's our answer. What is the coefficient? Highest power is x raised to 7 into minus 1. So A naught is minus 1. समझा ना students?
Yes.
Students समझा?
Yeah.
Any doubt?
Yes, sir. No, sir.
Right now. If delta equal to 11 factorial, 12 factorial, 13 factorial, 12 factorial, 13 factorial, 14 factorial, 13 factorial, 14 factorial, 15 factorial. Find number of factors of delta upon 11 factorial whole cube minus 4. Okay. Let us discuss this. Let us discuss this. From the first one, I will take 11 factorial common, which will come common from the first row. Second row, I will take 12 factorial common. Third row, I will take 13 factorial common. So if I take them common, what will I get? Delta equal to 11 factorial into 12 factorial into 13 factorial into inside 11 factorial is 1. 12 factorial may say if I remove 11 factorial, only 12 will remain. 12 into 11 factorial. 13 factorial may if I remove 11 factorial, 13 into 12 will remain. Similarly, either 1, either 13, either 14 into 13. Either 1, either 14, either 15 into 14 will remain. Correct, students? Now, 3 ones are there. Let's make 2 of them 0. Delta is 11 factorial, 12 factorial, 13 factorial. 2 of them zeros. 1, 12, 13 into 12. 13 into 12 is, I think, 156, right, students? Yes, sir. Now, what we do is we are going to do C2 we are going to do R2 goes to R2 minus R1, R3 goes to R3 minus R2. We're going to do this. So first row as it is, second row 0, 12 minus 13, 13 minus 12, 1. And 14 into 13, that is like 182 minus 156, I suppose. Correct? No? 13 to 12 is, 13 to 14 is 182 only, right? 170 plus 12. Correct only, no?
Yes, sir.
So,
Yes.
subtract करेंगे 6. 17 minus 5, 26. This will be 0. 14 minus 13, 1. 182 we have to subtract from 15 into 14. That will be 192 plus 210. 210 is the answer, right? So 10 minus 2, 8. 20 minus 18, that is 28. Correct, students? Now let's expand them. Expansion is very simple. Multiplication of these two minus multiplication of these two, because we are expanding with respect to this column. That's going to give us 2. So delta is turning out to be 2 times 11 factorial, 12 factorial, and 13 factorial. Now tell me, what is delta upon 11 factorial whole cube? That is what? 2 into 11 factorial is gone. Here 12 into 13, here only 12 will remain, sorry. In the next one, 12 into 13 will remain. Correct? From each one of them, I removed 11 factorial. Yes or no? We need what? 11 factorial, delta upon 11 factorial whole cube minus 4. Correct now. So let us try to do the calculation. So minus 4 is 2 into 12 into 156 minus 4. Can somebody calculate this and tell me what is the answer? 2 into 12 is 24. 24 into 156 is 3744 minus 4 is 3740. And 3740 is such a nice number. We need factors of this one, right? Let's prime factorize it. What is the, it's such a nice number, that is 11, it is divisible by 11 into 340. Correct? Na? So 11 into 17 into 20, 20 is 2 square into 5. Correct, students? So number of factors of this number is what? Number of factors. We know in PNC we learned it, powers ka 1, add 1 and uska multiply. Correct, students? P1 plus 1 into P2 plus 1 into so on. So this is 2 into 2, 4, 4 into 3, 12, 12 to the 24. That's what answer is. Right. One a square cos of p minus d into x cos px cos of p plus d into x sin of p minus d into x sin px sin of p plus d into x depends on option A, option B, P, option C, X, option D, D. Try this one. See, what I'm going to do is, I'm going to expand it blindly. So, expand with respect to that to first row. If I expand, what will I get? 1 into cos A sin B, sorry, sin A cos B minus cos A sin B. Correct? Na? Sin of P plus D into X cos Px minus cos of P plus D into X minus sin Px. Sorry, into sin Px. Correct? Minus A into
Yes.
determinant of these 4 elements, right? That is cos P plus D into X sin P minus D into X. Sorry, my mistake. sin p plus d into x cos p minus d into x minus sin p plus d into x, sorry, sin p minus d into x cos p plus d into x plus a square into determinant of these four elements. That is multiplication of these two. Sin px cos p minus dx minus cos px sin p minus d into x. This is like sin of a minus b formulas everywhere. Sin a cos b minus cos a sin b. So we'll write that 1 into sin of a minus b formula is px plus dx, पहला वाला angle minus second angle px minus a into sin of px plus dx minus px plus dx plus a square into sin of px minus px plus dx. You can see px getting cancelled, px getting cancelled, px getting cancelled. What are we left out with? Sin dx minus a sin 2 dx plus a square sin dx. What are the variables it is dependent on? It is dependent on a, it is dependent on x, it is dependent on d, but not on b. Is it clear, students? Right. Try this problem. Find 1, 1, 1, 2 raised to x plus 2 raised to minus x whole square, 3 raised to x plus 3 raised to minus x whole square, 4 raised to x plus 4 raised to minus x whole square, 2 raised to x minus 2 raised to minus x whole square, 3 raised to x minus 3 raised to minus x whole square. I'm sorry, 4 raised to x minus 4 raised to minus x whole square. Sorry. One thing I will do is 2 raised to x plus 2 raised to minus x whole square. Let's see it. Okay. That is, or we don't need to do like this also. Just tell me a plus b whole square minus a minus b whole square करोगे क्या आता है? This is a square plus b square plus 2ab. This is a square plus b square minus 2ab. A square plus b square कट जाएगा. 2ab minus of minus 2ab. This will turn out to be 4ab. Correct, my students? A plus b whole square minus a minus b whole square. Not something very great formula, but it is simple. In this, I'm going to use similar one. I'm going to do R2 goes to R2 minus R3. What am I going to get after that? 1, 1, 1, R3 as it is. Now, R2 goes to R2 minus R3, correct? Huh? That's like a plus b whole square minus a minus b whole square, correct? Huh? So if I do that for any one of them, 2 raised to x plus 2 raised to minus x whole square minus 2 raised to x minus 2 raised to minus x whole square करेंगे, answer is supposed to be 4a into b. 2 raised to x will be gone, answer will be 4. Imagine 2 की जगह 3 है, answer is same because 3 raised to x and 3 raised to minus x will get cancelled. 3 raised to x and 3 raised to minus x will get cancelled. The moment I take 4 out, they are going to be 1, 1, 1. Answer is 0, students. 2 rows will be same. Is it clear, students?
Yes.
Time up. Prove that a, b minus c, c plus b, a plus c, b, c minus a minus b, b plus a, c equal to a plus b plus c into a square plus b square plus c square. Listen to the first step. First step, what I'm going to do. In my first step, I'm going to do one thing. C1 goes to AC1 plus BC2 plus CC3. Now here we are not maintaining C1 coefficient same. That means 1, if we are not maintaining 1 in the formula. So we are supposed to divide with whatever that is coefficient. What is the coefficient? A. Divide with that. That will be 1 by A times. Okay. Now let us understand what should we write in the first element. A into C1, A into A, B into this, B into B minus C, plus C into C plus B. Simplify it. A square plus B square minus BC plus C square plus CB. These two cancel. We are going to get A square plus B square plus C square. B minus C, C plus B. Similarly, I'm going to try for the second one. A into A plus C, B into B, C into C minus A. I'm going to get what? A square plus AC plus B square plus C square minus AC. We are going to get A square plus B square plus C square here also. B, C minus A. Then what I'm going to do? Third element. A into A minus B, B into B plus A, C into C. Correct? I'm applying the formula everywhere. So we are going to get A square minus AB plus B square plus AB plus C square. AB cancel. We are going to get A square plus B square plus C square, B plus A, C. This is the answer. Now we can take A square plus B square plus C square common. What are we going to get? A square plus B square plus C square common upon A. 1B minus C, B plus C. 1B, C minus A. 1B plus A, C. Here's the thing. Now 3 1s are there. Our ideal strategy is like making 2 of them 0. Correct? No? So let us do that. R2 goes to R2 minus R1. R3 goes to R3 minus R2. That is A square plus B square plus C square upon A. One my Taylor row is not going to change. This is going to be 0, R2 minus R1. If I subtract this, B cancel, plus C I got. And similarly, if I going to subtract this one, what will I get? C minus A minus B, C minus A minus B minus C. C cancel. We are going to get minus of A plus B. Correct? Now, R3 goes to R3 minus R2. So, this here it will be 0. Subtracting this, I will get A. Subtracting this, I'll get A back again. Correct? Any doubt? So, now what we can do is we can take A common from this. Observe it. We can take A common from this and cancel that A outside. So, we will get A square plus B square plus C square into A got cancelled. B minus C, B plus C, 0 C minus of A plus B, 0 1 1, and expand using this column AD minus BC. So we are going to get A square plus B square plus C square, C minus of minus A plus B, that is A square plus B square plus C square into C plus A plus B. Did you understand, students? Students, did you understand?
Yes, sir.
Yes, sir.
It's a very good question. And the technique is also good. If A comma B comma C belongs to R, A square plus B square plus C square equal to 1, prove that AX minus BY minus C, BX plus AY, CX plus A, BX plus AY, minus AX plus BY plus minus C, CY plus B, CX plus A, CY plus B, minus AX minus BY plus C equal to 0 is a straight line. And X comma Y also. X comma Y are actually coordinates. They belong to R. Okay, they are not complex or imaginary. Now, how do we solve this? Similar technique, we are going to use similar technique. I'm going to apply C1 goes to AC1 plus BC2 plus CC3. If I apply, what will happen? ध्यान से observe करो. 1 by A से divide करेंगे, correct? Correct? A times first one, A square X minus ABY minus AC. B times second one, B square X plus ABY. C times third one, C square X plus AC. AC cancel, ABY cancel. We are going to get A square plus B square plus C square into X. Other two elements as it is, BX plus AY, CX plus A. Correct? Now, similarly, I am going to do the second row also. A times the first element, A into BX plus AY, that is ABX plus A square Y, and B into second element, minus ABX plus B square Y minus BC, C into third one, plus C square Y plus BC. BC cancel, ABX cancel. We are getting what? A square plus B square plus C square into Y. Other two elements as it is, minus AX plus BY minus C, CY plus B. Now third element. Third element, what are we going to do? Same, A into first element, ACX plus A square, B into second element, this one into B, BCY plus B square, and C into third element, minus ACX minus BCY plus C square. BCY cancel, ACX cancel, we are getting simply A square plus B square plus C square. CY plus B minus AX minus BY plus C. Understand, students? First step.
Yes.
We know one thing, A square plus B square plus C square is 1. I'm going to use that. Since A square plus B square plus C square is 1, this will turn out to XY1 BX plus AY minus AX plus BY minus C, CY plus B, CX plus A, CY plus B, minus AX minus BY plus C. Now observe properly. AY, BY, sorry, BX, BY, B. Okay, CX, CY, C. These can be removed in one step. How you know? I'm going to do C2 goes to C2 minus B times C1. If I do B times C1, what is going to get subtracted? B times X will get subtracted, B times Y will get subtracted, B times 1 will get subtracted. Fair enough? Similarly, C3 goes to C3 minus C times C1. The highlighted portions will get removed. See that. We are going to get 1 by A times XY1 AY minus AX minus C CY AB minus AX minus BY. Any doubt on this, students? Students, any doubt?
No, sir.
No? And one more step is pending. ध्यान से observe करो. I'm going to do R3 goes to R3 plus X times R1 plus Y times R2. R3 goes to R3 plus X times R1 plus Y times R2. How this is going to help us? Observe karo. 1 by A times, see first two rows we are not changing. Third row, see R3 is 1, X times R1, X square, Y times R2, Y square. 1 plus X square plus Y square. Here, what are we going to get? R3 Cy, x times R1, x times Ay, y times R2 minus Ax minus C. So Cy plus Ayx minus Ayx minus Cy, cancel, 0. Of course, here what will I get? Minus Ax minus By, x times R1, x times A, y times B, add karo. Cancel, 0. समझ रहे हो ना? Now expand. With respect to which row? With respect to third row, you expand. Just that this determinant will be left out. AD minus BC. So we will get 1 by A into x square plus y square plus 1 into A by B minus into minus plus A square x plus AC. This is given as 0. Now I can take common from this, A common from this and cancel it. We are getting x square plus y square plus 1 into Ax plus By plus C we are getting. If this is 0, of course this can't be 0 because sum of perfect squares and x and y are real numbers. So we will get Ax plus By plus C equal to 0, which is a straight line.
Yes, sir.
Add. If A square plus B square plus C square equal to 1, prove that determinant of A square plus B square plus C square into cos theta, AB into 1 minus cos theta, AC into 1 minus cos theta, AB into 1 minus cos theta, AC into 1 minus cos theta, B square plus C square plus A square into cos theta, BC into 1 minus cos theta, BC into 1 minus cos theta, C square plus A square plus B square into cos theta is independent of A, B, C. Let us discuss this. So we need to prove that it is independent of A, B, C when we simplify. Okay, A square plus B square plus C square is 1. What I'm going to do is, let me copy the determinant ones first. In this, I'm going to take A common from this, B common from this, and C common from this. I'm taking A common, B common, and C common when I'm from rows. Okay, and at the same time, I'm going to multiply A to the column, B to the column, and C to the column. How does this change? Observe. For the first element, nothing is going to change. Why? A is being taken common and A is being multiplied also back. So we are going to get the same thing back again. Are students? Now, when we talk about this particular element, A is going away and if B is being multiplied, that means we are going to get B square. Correct? For here, what is happening? A is going away, C is being multiplied. Originally, one C is there. So this will become C square into 1 minus cos theta. Here, what is happening? B is going away, A is being multiplied. A square into 1 minus cos theta. B is going, B is multiplied. So no problem. It will remain same. Here, we are taking B away and multiplying with C. So C square into 1 minus cos theta. Now, you got the pattern, right? Here, C of and A in. A square into 1 minus cos theta. And C of and B in. B square into 1 minus cos theta. C square plus A square plus B square into cos theta. Is it clear, students? Students, is it clear?
Yes.
Yes, sir.
Now, what are we going to do? I'm going to multiply. I'm going to do row operations, or we can do column operations. We can do anything. Here, I'm going to do row operations. Okay. So how am I going to apply? R2 goes to R2 minus R1, or no. Let's do all columns, add all columns. That is easiest. C1 goes to C1 plus C2 plus C3 करो. क्यों पता है? When I do that, A square plus B square plus C square into cos theta plus addition of this is what? B square minus B square cos theta. Next wala plus C square minus C square cos theta. These two will get cut with this. We'll get A square plus B square plus C square. समझ रहे हैं ना? Students? Even next one is going to give you same thing. A square plus B square plus C square. Even next one is going to give you same thing. You can check it out. Like for example, I will show you this addition of all these three elements. A square minus A square cos theta plus B square plus C square cos theta plus A square cos theta plus C square minus C square cos theta. C square cos theta, C square cos theta, A square cos theta, A square cos theta cancel. A square plus B square plus C square. Is it clear? So that's what our first step is. That will make it much better. I'm going to make this one A square plus B square plus C square. A square plus B square plus C square and A square plus B square plus C square. Rest of the four elements are going to remain same. Yes or no? Any doubt on this, students? And we know first A square plus B square plus C square is what? Given as it is 1. Correct, right? So the first element is going to be 1, 1, 1, and rest of the four elements are going to be same. Correct? Now, since 3 ones are there, we are going to make 2 of them 0. How? C2 goes to C2 minus C1. C3 goes to C3 minus C1. Let's do this. What we are going to get? Sorry, not C, R. My mistake. R2 goes to R2 minus R1. R3 goes to R3 minus R1. First row is not going to get changed. Second row में 1 minus 1, 0, 1 minus 1, 0. Now, this minus this, what is going to come? Just check it out. B square plus C square cos theta plus A square cos theta minus B square plus B square cos theta. B square cancel. We are going to get cos theta common, A square plus B square plus C square. But A square plus B square plus C square to 1 hai. Even though, let us write it. A square plus B square plus C square into cos theta. Correct, students? Now, this minus this is going to give us 0. Correct? Similarly, this minus this is going to give you 0. And what is left out? Left out is this minus this. Let us see what is it going to give us. That is C square plus A square cos theta plus B square cos theta minus ये वाला एलिमेंट को सेपरेट करना है माइनस सी स्क्वायर माइनस ऑफ माइनस प्लस सी स्क्वायर cos theta. C square cancel. We are going to get A square plus B square plus C square into cos theta. Correct? And A square plus B square plus C square is 1. We don't need to write that also. Actually, we'll expand with respect to this column. So just that determinant of these, this determinant will be remaining. So we are going to get A square plus B square plus C square whole square into cos square theta, which is nothing but simply cos square theta. Now we don't have any ABC, independent of ABC. Are you understanding, students?
Yes.
Yes, sir.
Right. Find number of positive integral solutions x comma y comma z of possible for equation determinant of x cube plus 1 x square y x square z x y square x z square y cube plus 1, yz square, y square z, z cube plus 1 equal to 11. Try this, students. See, this is positive. Number of positive integral solutions x comma y comma z possible for the equation x cube plus 1, x square y, x square z, xy square, x cube, sorry, y cube plus 1, y square z, xz square, yz square, z cube plus 1. Right. See, this is the equation that we have when we are looking at positive integral solutions. What I'm going to do is, in the first step, I'm going to take x square common from this, y square common from this, and z square common from this. Okay, x square, y square, z square common later, and I'm going to multiply x square to this, y square to this, and z square to this. How things are going to change after this? First element, no, not much change, no change, because x square common liya, x square ko multiply bhi kiya, so we are going to get the same thing back again. But in the second one, we took x square out and we multiplied with y square. That means x square is gone, y into y square, y cube. For the third one, we took x square out and we multiplied with z square. This is going to turn to z cube. Now for the fourth element, what did we take off? We took y square and we multiplied with x square. So this is going to turn to x cube. This element is not going to change. This will turn to z cube. I guess you saw the pattern. This will be x cube, y cube, z cube plus 1 is given as 11. Correct, students? Which determinant is this? Standard determinant 5. What is that? 1 plus a, b, c, a 1 plus b, c, a, b 1 plus c. What is the standard determinant? 1 plus a plus b plus c, right? Remember, right? So this is going to turn to 1 plus x cube plus y cube plus z cube. This is given as 11. And x cube plus y cube plus z cube is equal to 10. We are interested in positive integer solutions. That means x, y, z are positive integers. What is the only solution that we can think of is 2, 1, 1. Check out 2 cube is 8, 1 cube is 1, 1. Addition is 10. And any arrangement is also an answer, right? 2, 1, 1 arrangements are what? 1, 2, 1 and 1, 1, 2. So 3 solutions. Clear, students?
Yes.
This is clear. Right.